What up, YouTube? We're going to keep on going on our LuaSnip series here. This is episode 2, and today we're going to be covering the real building blocks of creating custom and unique snippets inside of LuaSnip. We're going to be covering all sorts of things like choice nodes, function nodes, dynamic nodes, snippet nodes, and a few more tips and tricks that you'll need to stay till the end of the video to see. I hope you enjoy this and learn a lot, but let's get right into the action today. To really showcase the power of LuaSnip, I want to start with a quick example. Let's say we have a list of choices that we want to be able to choose from for different ways that we could format to do, which is shown right here. Writing this to do, we can normally expand and cycle through the choices as needed. However, LuaSnip does more than that. It also integrates with vim.ui.select, which allows us to do something very cool like the following. We can actually select any of these results by typing and filtering using telescope and then insert that back in. This is the power of using snippets created in Lua integrating within the NeoVim ecosystem. With that quick example, let's hop to the rest of the tutorial. The first thing that we're going to be talking about is choice nodes. So the way that you first access these choice nodes, generally I do something like local c equals ls.choiceNode, just like how we have been importing things in the shorthand. You'll get used to the shorthand as you use it a little bit more, and it'll make your snippets eventually easier to read. So the way that you actually use this is by calling choice node, and the first argument will be some position. So we had talked about before where you need to do like 1, 2, or 3 to say when you want the cursor to enter this node. And then you pass a list of the choices that you would like to be able to choose. Now, the thing is for this, you'd think at first you can just pass in strings, but no, each of the things within the list must be a snippet node or a node type that we've talked about before, like choice or function or insert. We'll talk about more of those today. So an example of how you could actually use this would be you do something like choice. Let's just do the first position, and then we could say either it could be hello or hi. And I'll show you how to do that right now. So our first example, of course, is going to be making a snippet for Rust. Did I say Rust? Hello, it's me, Rust here. And what we're going to be doing is actually making some snippets to make creating tests a lot easier in Rust. Of course, when I write Rust, not only is my code safe, but it's also well tested because that's what kind of programmer I am. I do find it quite tedious to write out the entire structure of the testing for each Rust file or module that I'm working in, and so I wrote some snippets to make that a bit easier. Let's walk through how we can use choice nodes to actually make it so that regardless of what we're doing within these tests, it's quite easy to get them set up. So the first thing that we do is import all the nodes that we've already talked about in the previous video. If you haven't watched that video, check the link in the description and head over there right now. So in this case, what I want to be able to do is sometimes when I'm creating a new module level test, I want to be able to bring everything immediately in a new scope, and sometimes I don't want to bring it into the new scope. So what I have is a snippet called mod test. When I expand this snippet, you'll note that I have this little hover here that tells me where the current choice is. We're going to go over in the next video how to customize that. But in this video, I'm using this to point out where my cursor currently is. I can press Control L to cycle through the options. This would be bring those things into scope, and this would be don't bring those things into scope. So in this case, I want to bring them into scope, so I leave that there and I jump to the next spot. It's actually quite straightforward once you understand the basics that we've covered so far and then this choice node. So I make a new snippet within my Rust snippets, right? So this is only available in Rust, and I call it mod test, right? This is the trigger that I want to expand on. And then I use the format helper that we explained previously as well. A couple small notes is you'll see that I use 2 curly braces here. When you do this inside a format, that means insert a literal curly brace, right? So Rust uses curly braces, so we need to be able to insert those directly. And then you'll see basically the 2 positions where I'm telling LuaSnips, hey, I would like to put snippet nodes here. In this case, the first one that I'm going to place in this position here is this choice node. So we see C here, right? And then 1, as in this is the first place that I'd like my cursor to go. And then we have a list of options of things that we might want to put there. In my case, the only 2 options that I want to have are use superstar. I like to think of myself as a superstar, so I love reading that to myself. Or just put nothing. And you can see how when we were cycling through these, when we write mod test and we cycle through, it cycles through either that use superstar or nothing. Then the last bit is, as we've talked about before, that I0 just means put my cursor here once we're all the way done, and this would be where I could write the next test. Function nodes are useful when what you want to do is to be able to calculate some value and then insert that into the text. Now, the way that we first get them is we access them very similar to the way that we've been accessing other nodes. We're going to just do local f equals ls.function node. And the way that we call these things is that we actually pass a function into the first argument for the function node. And then we also pass a list of nodes that we want to send this function later. And I'll show you what we mean by that. At first, though, the first thing that we're going to be doing is just showing how you can use function node to do something like calculate the current time as a simple way of using this. So we're going to be using function node to return the current time. The reason that we'd want to do this with the function node is because time change. And so you don't want to actually calculate the time at startup and then keep inserting that snippet over and over. You want to calculate that at the time that you're executing the snippet and return that value. So function nodes allow us to do that. So let's create a new snippet that's going to be available for all of our different file formats. And we'll just call it cur time or something like that. You can call it whatever you want as well. And we don't even need to use format because in this case, we're just going to literally return the time as it is. So we use f, which is our function node, and this takes a function as the first argument, and it needs to return a string. So if, in this case, we could say to do and end, and then this would be done. If we run this file and I type cur time and expand, it says to do. That's not that exciting, but what we can do instead is we could do something like in Lua, you can use os.date, and then you could say something like %d for the day of the year, and then %h, %m to give you the current hour and minutes of when you're doing this. So if we re-execute this and we write cur time, now notice how it expands out whatever that function is. And if I did this again later, it would send the updated time. We can also use function nodes to do really interesting things that interact with other nodes that have already been expanded or will be expanded as we work through the snippet. For example, in the last video, I showed how we could make a repeated node, although I'm going to call this same. And these two things will sort of mirror the existing nodes that you have. So if we created our own little helper function called same, and we would pass in the index of which node we want to replicate, this needs to return a node so that it can be inserted successfully into LuaSnip and evaluated at the right time. So we use function node to do this, and remember the first argument is a function, and we're going to put to do here because we don't know what to do inside of here. So I haven't yet introduced that the second parameter to a function node is a list of the indexes or positions that you would like to pass later to this function. So if you're familiar with things like currying, this is sort of that general idea where we're basically assigning a function and we're binding certain values to be passed later to it. So in this case, we're going to be passing index directly to this function. And then at this point, we don't really know what the inside of this looks like. So let's do something like print vim.inspect arg. Okay, and let's pass in arg just like this, okay? So this will allow us to print whatever's going on whenever we call same. So let's make a new snippet, and we'll call it same test. And what we need to do here is we need to have two separate nodes. So let's do a format, and we'll say example here, and then function here, and we'll pass those two. The first node will be an insert node that we're just going to be able to type into. So we'll say 1 for this, right? And then we're going to call same. Now remember, same is basically a higher order function, right? Because it's a function that returns a function. And so we can use same 1. This means please refer to this value, whatever is in the first position. So now if we run same test, we can expand it to say, okay, so we see example and function just like we've got in our snippet. And right now we just have this returning nothing because function nodes have to return something. If I start typing ABC, notice how that ABC is what's getting shown here. And so effectively what happens is whatever we pass to this index function is going to get passed through here, and you're going to receive the text that is currently in that node. So if we move out of this one and instead we did something like let's pass index and index again, which would be a bit goofy, but this just gives you the example. We type same test and we expand. Notice now how this is basically passing in that first node multiple times back into this function. Okay, this allows us to get the text as it's being evaluated and do dynamic things with the text. So the simple solution here, instead of just returning nothing, which will never work, let's try returning arg. And so we get the first argument here, and we'll just say put whatever was there into this spot. We can remove the to-do and delete our extra index. If we re-execute this, same will have changed now. And so as we type same test, we'll be able to say hello, and look how it updates in this spot. So now we have these two nodes mirroring each other. You could, of course, do something like shortening or splitting by dots. Let's do that in 1 second. In this case, I want to show you a cool way that you can actually make a really short snippet for Lua that allows you to do a cool smart import kind of thing. So in this case, let's create a new snippet for Lua. And what we're going to do here is I want to call this one rec, and this is going to be very similar to what we did in the last video, except this time we're going to be able to pull out the last name of a list of imports and use that as the local variable name. So just to give you an example, if I do something like local, and we'll leave that blank for now, require telescope.pickers.builtin. Now I might do something like, I would like to just call this built-in. Okay, before we didn't have any capability to calculate what built-in should be. But in this case, we're going to create this kind of idea. So we're going to use format again because this makes life a lot easier. We're going to say local here, and this is where we're going to place the local variable name that we're going to be using, equals require, and then let's do something like we're going to put in our text here. The nodes that we have is we're going to call this one a function node, and it's going to take some function here, which is arg, but we could really call this import name or something like that. And for now, we're just going to return nothing because we don't have any idea what we're supposed to do here yet, and that's okay. And then we're also going to pass in I1, and that's going to be the part where we start typing, okay? So once we close this, we're able to run this, and if I type rec, I can say telescope.pickers.builtin or whatever this kind of thing is that you wanted to do. Doesn't do anything exciting yet because we don't return anything cool. So now this is where the fun function, get it? The fun begins. We're going to use the trick that we just learned before for copying the value between two different nodes to begin to insert the text again at the beginning of the require. So what we can do here is instead of just passing no nodes to here, we need to pass the first node into here, okay? So this means return to me whatever is the text inside of that first argument that's passed. So if we execute this, we can see something like this, and we can start typing telescope, and it's like, cool, we are getting those values. The problem is this is not valid Lua. In fact, it's also not what we wanted. What we want is only this last little bit. But what's cool is you already know how to solve this kind of problem because you can just write some Lua code to calculate what that value is. So in this case, instead of just returning this name directly, we could say something like local parts is vim.split. We're going to split this string, right? So that'll be the telescope.builtin. We want to split that on dots and do that literally, right? So that just means split it on only dots, not on any character. This will give us each of the parts. And what we can do now is we can return parts, the last entry in parts, or just some empty string so that we don't have any errors in case there wasn't any matches. So now if we were to run this, we would actually get an error because if you remember from when we were printing these off, this area right here is actually a table. It's a list of each of the lines. Now in this case, we only want the first line of text. So we need to make sure that we put another one to access the first line of the text here. When we do this, we're able to run this to be able to do something like rec. And now when we start typing telescope, we get exactly what we'd expect. But when we type a dot, everything deletes and we can start typing built-in, and that's how we would get this built-in value. So this is really exciting because now whenever you wanted to require something, you could just type require telescope.builtin.nested.other.thing.blah.x.y.z.foo.bar.the primogen. It is big! And it will always keep on splitting and giving you the last value. This is where I think the really exciting bits of LuaSnip come to life, is because you already like to configure and write these little things to make your life happy. Now you can use all of that Lua knowledge to interactively generate whatever you need to be able to fit your coding style. And now we're going to talk about dynamic nodes. And this is where I really feel like LuaSnip just feels like magic. Just magical when we get to this point. Okay, and so I'll show you how we use this. In fact, I can show you a really cool example of how we use it with Go, but first let's go over the basics. So throughout our usage, we'll use D as our shortcut for dynamic node. And as before, the first parameter that we're going to be passing to the dynamic node is its position. The second one will be a function, and then we're going to forward in the indexes or the args that we want to be able to pass into this dynamic node. And so in this case, though, the difference is dynamic nodes don't return strings, they return snippets. Before we get to showing that really complicated Go example, first though, I want to show you how we can begin to use these dynamic nodes to create really surprising and cool snippets. So of course, to be cool, it has to be a Rust snippet before we can get to Go. So let's show you a Rust example. In this case, what I have is I want to create a snippet that just generates a new test case in Rust. So all this one's going to be doing is generating a new test tag and then filling in a few places that we can write to make this test. So if we open up a Rust file and we open this up here, I want to add a new test. I type test, I hit expand, I can say test another thing. And then I could say, assert equals same thing here. Just assert this to be true. Okay, so that's how we can add a test. But Rust also allows you to, if you'd like, specify a return type of some sort of result here. And maybe I want to do something like this, result, and then some sort of error or whatever. There's a lot of different things that could go in this location. However, I'm often using some library that's just called use anyhow result. I have no idea how this works. We've talked about this in my old videos for Advent of Code. I don't know what's going on there, but it makes my life a lot easier. And so in general, then instead of having to specify a result like this, we can just say result like that. However, not every project that I use for Rust uses anyhow result. So I only want that to be an option when I have anyhow in this file. So let's see if we can create a dynamic node to fill in this little spot right here that allows us to dynamically determine whether that should be an option for our choices. Let's go ahead and try that out. So what we're going to do is we're going to write this function here, get test result. I'm going to write this above just for clarity. And it's going to be past which index we want to place this result. We've got the first index, which is going to be the test name. And now we need to put something here that's going to be the dynamic node that we want to generate based on what kind of options we want to give ourselves. What we're going to do now is first, let's just return a very simple dynamic node that only gives us a choice between nothing and something that just uses the default result option. Okay, so to do that, we're going to do return D position, right? So this is the position where we want to be inserting this dynamic node. Okay, so that's the first part. The next part that we need to use is this new snippet node, often called SN. SN is actually what I sort of like to call snippet node. That's what the SN stands for. So S creates a brand new snippet, while SN is the snippet node that we can return from a dynamic node. When we do this, we can create a new snippet node. But instead of creating the snippet node directly, what we do is we pass a function to dynamic node that's going to return a snippet node for here. Okay, so in this case, a not very exciting snippet node would be something like we just say example. Okay, and this just puts text back into this snippet node result. So now when we expand test, we'll see that this just literally puts in the text that we had here, which was example, right, from the text node that we had. This isn't very exciting because we're not doing anything dynamically, but what you'll notice is that this was passed into this snippet node. So that's the first part. What we want to do to start making things more interesting is we can combine some of the different nodes that we've learned about before. So instead of just returning example, let's do something where we return a list of possible options, other thing, and maybe final. Okay, so now if we were to run this, when we execute this and we go back to test here, we're able to see that, okay, sure, we get to example, but now we can scroll through those other results. Once again, still not that exciting because this is static, but you notice how we're combining snippet node with choice node to create a new sort of combination. Now, this is where I hope things can get a bit more interesting. Let's combine our knowledge of what we know about NeoVim and our Lua scripting with these new tools that we've just gotten, okay? So let's do something like this. Local nodes is a list, okay? And we're gonna do something like table.insert nodes. We're just gonna put something in that's just an empty string. This will be basically the default return value for test, and it won't be anything. It'll just be that nothing's there. Then what I wanna do is I like to do something like, let's get all the lines of the buffer, 0, so we're gonna get all the lines, and then we're gonna iterate over them. Line in I pairs, lines do end, and let's see this. If we just want to check if any of the lines match anyhow result. Remember, that was sort of our idea of the other kind of return value we might have. So if we do line match anyhow result, then we're also going to insert into nodes this result like this. Okay, so this basically means, okay, since we brought anyhow result into this buffer, or at least likely, we could get a better match condition if we wanted to, but this works out all right here. Then we want to insert this text node that says we just want to use anyhow result, and we can break out of here. So now after we fix that, we're able to run our snippet. And when we go to the next section, notice how we have these choice nodes here. We're able to scroll through the results that we've dynamically generated. Now, one thing would be if we don't have anyhow result, maybe we should add a different result type that we might have, or we could add other options for other heuristics of Rust code that we commonly like. The point is not actually to create the world's most comprehensive Rust expansion snippet here, but instead that what you do is you use something that works well for your workflow that you've customized to know what you should expect whenever you're expanding your snippets. I think this is a really cool and powerful way to start iterating towards making exciting snippets for you, not what I think would be exciting. All right, and last of all, I'm just going to give you the briefest of brief overviews for my really cool Go snippet that we showed initially that calculates the return type based on treesitter and inserts defaults for that. Actually, a decent amount of the next and final video in the LuaSnip series will be focused on this snippet to show how we can combine all these things together. But I just want to show you a few of the ideas so you can start to play with it yourself. So the first thing is, because I had a lot of different snippets and a lot of different entries hopping around in this, I didn't actually use format. I just used a list of entries and then combined them all together as one list of nodes. And so you'll see that this is one of the first times that I've introduced you to one that has multiple different positions. So we'll see that the first place we go is val, and then we move to where error would be, and then where the function value, the name of that, and then the name of the function, and then to arguments within the function, and then we move to a new line and start an if statement. And what's cool is we use same, that same function that we just made earlier, to actually copy whatever we type as the name of error, in case we need to change the name, to use as the condition value for to use as the conditional within our if statement. And so you'll notice that we'll do if whatever was in 2, right, because this matches to the position, not equals nil, and then we do a new line, indent one more line, and here's where the big magic happens, which is our dynamic node. Now this dynamic node is in position 5, so it's where we go in the 5th spot, and what it takes as its arguments are actually 2 and 3. What this means is whatever inside of this node and this node is what gets passed to go ret vals. So when we go to here and we see these args, this is very important Even though we passed 2 and 3, that means they're getting placed as the first and the second items in a list. So the first and second items will be that error name and function name. And so if we dig a little deeper into Go result types, there's going to be a lot of treesitter specific logic here. And like I said, we'll talk a little bit about how you could think about doing these kinds of things in the next video. But basically, we find where the function nodes are. We ask how we map those nodes, and we do some cool stuff with some handlers that basically transforms what the name of these different values are. You don't have to worry too much about that, but ultimately what's exciting is we transform each of these different variable names. So if we saw an int as the return type, then we say we're going to return a text node that has 0. That's basically just the default value for int. And for error, we do some other things. And what's cool, right? So once again, this is how you should be thinking when you're interacting with complicated LuaSnips is I want to combine the building blocks that TJ has been so meticulously teaching me, right? We're returning different types of nodes within this dynamic snippet, which means we can return text nodes, but we can also return choice nodes. And this is what I love. This choice node here has the option to be either wrapped with this errors wrap library or just directly with whatever the error value should be. So I think that's the really exciting thing as we go through here, and we'll work on how does this work in the next video. But what's really exciting is this combination to allow you to build things that are really surprising and reusing many different aspects of NeoVim. You could even imagine trying to do things like asking the LSP for the definition of something, or asking for completion results, or running grep or other tools. And in fact, next video will show you doing some of exactly that. I hope you enjoyed this, and thanks for hanging out. And with that, that's another Take Tuesday in the bag. I hope you enjoyed it, and I hope you learned a lot of new stuff. If you liked some of the new things that I'm exploring, writing stuff out, taking time, whatever, please really let me know in the comments. I'm really looking to explore new ideas and new ways of creating content for you. I apologize that we didn't have a really funny, hilarious dad joke as you've come to expect from the series, but honestly, I'm just so far behind on this series that what I really want to do is provide you with the content and ideas that help you become a better NVimmer every day, and I didn't want to let the other parts of content creation get in the way of that. As always, the best way that you can support the channel is through GitHub sponsors. I receive 100% of the funds through there, so it helps me buy new lights and helps me set up cameras and buy cords and all this other stuff that I've been exploring with and having a lot of fun doing. And of course, pay Flip. Okay, yeah, we pay Flip, and that's good too. Don't forget to like, subscribe, smash the bell, of course. And honestly, the coolest thing for me to see is when you post this on Reddit or Twitter or other places where you're recommending it as a really great tool to learn about NeoVim. That makes me happy and helps more people find out about what we're doing here. Thanks, everybody. I will see you next week.